All right, let's talk crypto, but not just what it is. I want to know how it actually works. Like, how on earth do you build trust when there are no banks, no governments, nobody in charge? Well, today, we're going to figure that out by inventing our very own digital currency right here, from the ground up. By the time we're done, you'll see exactly how security gets baked right into the system, step by step.
I mean, that's the big one, isn't it? If you don't have a bank or some government agency making sure everything's on the level, how do you trust it? What stops it from just becoming total chaos? Well, the answer is, it's just this incredible mix of some really clever math and some even smarter incentives.
Think about the money you use every day. You're basically trusting a middleman, right? Your bank. They keep the records safe. Cryptocurrency's whole deal is getting rid of that middleman. So if we're going to build our own currency, the very first thing we need is a totally new way to keep records.
Okay, Section 1, the public ledger problem. So to get our currency off the ground, we obviously need a way to track who has what. Let's start with the simplest idea possible, a shared public ledger. You can just picture it like a big communal notebook or maybe a website where you and all your friends just write down who owes who what.
So imagine this public website. Anybody can go there and just add a new entry. Alice pays Bob $20. Bob pays Charlie $40. Simple. It's totally open, super transparent. Everybody can see the entire history of every transaction. Seems perfect, doesn't it? Well, yeah. But this wide open system immediately runs into a huge problem.
Because if anyone can add a line, what stops Bob from just typing in, Alice pays Bob $100 without her permission? Absolutely nothing. And without some way to actually verify who approved a transaction, our little public ledger is completely useless. The whole thing just falls apart right there.
All right, Section 2, securing it with signatures. Okay, so we need a way to prove a transaction is legit. And this is where the first piece of, well, cryptographic magic comes into play. It's called digital signatures, and this is the key to solving our fraud problem and finally making our ledger trustworthy. You can think of a digital signature as being kind of like a handwritten one, but honestly, it's way more secure. It's not just a picture of your name. It's a totally unique cryptographic proof that gets created for every single transaction. You can't just copy and paste it onto some other payment. It doesn't work that way.
And here's the basic idea of how it works. Every single user gets a pair of keys that are mathematically tied together. You get a private key, this is your secret, you keep it totally to yourself, and you use it to sign any transaction you make. Then you have a public key, which, as the name suggests, you share with everybody. Anyone can use your public key to check and make sure that your signature is the real deal. Now check this out. To understand just how secure this is, look at this number. There are 2 to the power of 256 possible private keys. That number is, it's so big it's hard to even wrap your head around. It has more possibilities than there are atoms in the known universe. So, the chances of someone just guessing your private key, it's basically zero. It's just not going to happen.
Okay, Section 3, decentralizing the ledger. So this is great. Now, thanks to these digital signatures, every single transaction on our ledger is verified and authentic. We've solved the fraud problem. But there's still a big trust issue we haven't dealt with. Who runs the website? Who controls the server where this ledger is stored? If you trust just one person or one computer, well, that's a massive single point of failure.
So the solution is pretty radical, but it's also kind of brilliant. You just get rid of the central server entirely. Poof, gone. Instead of having one official copy of the ledger, we give everyone in the network their very own copy. And that, right there, is the core idea behind decentralization.
But wait a second, this creates a whole new puzzle, right? If everyone has their own copy, how do we get thousands, maybe millions of people to agree on the exact same history of transactions in the exact same order? What happens if my copy says one thing and your copy says something else? How do we all agree on what the real history is? This is the central challenge for any decentralized system, getting everyone to agree. It's called achieving consensus. So, how do we solve that? This brings us to Section 4, the proof of work solution. This is the genius idea that Bitcoin introduced to the world. And the core concept is actually pretty simple. The rule is, we all agree to trust whichever version of the ledger has the most computational work put into it, the one that was the hardest to create.
You can think of it like a massive, ongoing competition. To have the right to add the next page of transactions to the ledger, people have to spend real-world resources. We're talking serious computing power and electricity to solve a really difficult math puzzle. And here's the crucial part.
The puzzle is incredibly hard to solve, but once someone finds the answer, it's super easy for everyone else to look at it and go, yep, that's correct.
And this whole process, it's called mining. People called miners are all competing to be the next one to add a new block or page of transactions to the ledger. So they bundle up all the latest transactions and they race to solve that puzzle. The very first person to solve it gets to broadcast their new block to the whole network. And for all that effort, they get a reward, some brand new, freshly minted cryptocurrency.
And that is why we call it a blockchain. See, each new block is cryptographically chained to the one right before it. This creates a secure, unchangeable chain. Now, because of that link, if a bad guy wanted to go back and change an old transaction, they wouldn't just have to resolve the puzzle for that one block. They'd have to redo all the work for that block and every single block that came after it. It's almost impossible. So the rule for the whole network is simple. The longest chain always wins. That's the one we trust.
Okay, Section 5. Why decentralized trust matters. So let's step back and put all these pieces together. We've got digital signatures, we've got decentralization, and we've got proof of work. How do they combine to create a system that is just so incredibly difficult to cheat?
Well, to cheat the system, to go back and rewrite that history we talked about, an attacker would need to have more computing power than everyone else on the network combined. This is what's known as a 51% attack. And for a huge network like Bitcoin, the amount of money you'd have to spend on computers and electricity is just astronomical. It's so expensive that it makes no sense. The system is cleverly designed so it's always more profitable to just be honest and play by the rules.
So, here's the big takeaway. It's all about these layers of security, each one building on the last. You have digital signatures to prove who sent what. You have decentralization, so there's no single point of failure to attack. You have proof of work to make changing the past incredibly expensive. And finally, you have that simple rule, trust the longest chain, so everyone agrees on one single version of the truth. In the end, trust isn't in a person or a bank. The trust is literally built into the mouth of the system itself.
And that brings us to the really mind-blowing question, doesn't it? Because this whole idea, it's about way more than just digital money. It's a blueprint for programming trust itself. So if we can create money without needing a middleman like a bank, what else could we build without one? Think about things like voting systems, or tracking products in a supply chain, or even our own digital identities. It really makes you wonder, what other parts of our world could we rebuild from the ground up?